It's got energy, there's physically energy there, but there's no contrast to work with, so you actually can't get at it. So heat engines don't work because you've got no contrast. So unless there's a very cold place nearby, although it is true that the planet's oceans are a heat engine. The warm seas at the tropics are exporting heat to the cold seas at the poles, and that's what drives most of our weather, that shifting around of energy from hot to cold. But you can't just take a pot of water at a temperature and get energy out of it, even though it might have lots of energy in it. So there are heat contrasts in the ocean, and you could get energy out of those because there's a contrast, but the ocean won't do it for itself because it's stable.
Okay, so that's not possible, Rob, but what we're talking about here is sort of big schemes, geoengineering, manipulating the planet for generating useful energy or changing it in a positive way. Andrew, any other geoengineering solutions that might appeal?
Well, I mean, you hear, don't you, about ideas of, if global warming gets really bad, of trying to block out some of the sun's light with various schemes like spraying aerosols into the atmosphere. And the conversation we've just had reminds us what a fundamentally bad idea that would be, because it's not like you can just sort of put things back to how they were. All you can do is maybe, yeah, sure, you can filter out some of the incoming energy from the sun, but that's good energy. That's energy we can use. There's no sense in which that's a replacement for having too much heat energy hanging around on the Earth.
Okay, so that's a geoengineering topic. I'm just going to do a quick plug. Next week's BBC Inside Science is a special recorded live from the Kew Gardens Literary Festival. Geoengineering is going to be one of the key topics up for discussion, so do tune in then. Okay, so we're almost